So what we're going to do now is we're going to continue our discussion about ReentrantLock. And in particular, we're going to talk about some of the key methods that are defined by the ReentrantLock class. These will be important for assignment 2B. The methods are very simple. It's basically the methods that are implemented by the lock interface, which are lock and unlock, and a couple of variants of that. These methods are also used, lock and unlock and so on, try-lock, are also used by other synchronizer classes like ReentrantLock and some of the other classes that are part of Java's synchronizer locking framework or package. These methods all pretty much just forward on to the underlying methods that are inherited by the abstract or inherited from the abstract Qt synchronizer framework. Lock acquires a lock if it's available. If the lock is not available, then what the lock does depends on the fairness policy. So if it's non-fair, if that's what you selected when you started, when you created the instance of ReentrantLock, which is the default if you don't do anything to the contrary, then it'll do an unfair lock, which uses a spin lock internally, so kind of gives whoever is around gets the first chance, irrespective of the time that others might have been waiting. Fair implementations, in contrast, will, if people are trying to wait for something and the lock's not available, then the waiters will park themselves on a wait queue that's served in FIFO order. Lock is not interruptible, so you can't disturb it. It'll just block even if someone tries to interrupt the thread. As the name suggests, lock interruptibly will do the same thing lock does. However, if someone interrupts the thread, then the lock will automatically be, or rather not the lock, the call will return with the interrupted exception. And we'll talk more about interrupts later when we talk about managing the Java thread lifecycle. That's a more advanced topic for threading. Try-lock acquires a lock only if it's not held by another thread at that moment. So when try-lock is called, if the current lock owner is nobody, then whoever calls try-lock will be the one to get it. And that particular method, the untimed try-lock, the one that doesn't take any parameters, doesn't honor the fairness setting. So even if you set the lock into fair setting, this will barge in and will have the opportunity to jump ahead of people in line. Not entirely sure why they did that, but that's the way it works for various reasons. And then finally, unlock attempts to release the lock. So as you can see here, it just goes ahead and says release, giving back one token or one permit back to the locking mechanism. And the reason why I said attempts to release the lock is it might not actually be released because of several reasons. Number one, if you don't currently own the lock, then an illegal monitor state exception will be thrown. So if you try to release the lock and you're not the owner, then things won't work. Likewise, if you call unlock and it's a recursive lock and the lock count has not dropped to 0, it also won't be released at that point. So one of the consequences of unlock is that reentrant locks are fully bracketed. That means the thread that owns the lock must be the one to release it, just like the restroom analogy that we've used previously. There are also a bunch of other ReentrantLock methods, and these methods are above and beyond what goes into Java's synchronized statements and synchronized methods. So as you can see here, we've got try-lock, which takes a timeout, and this particular method does honor the fairness settings, so it doesn't barge. In fact, if you want to get the fairness setting equivalent of the try-lock with no parameters, you can simply call try-lock with 0 for the timeout, and that'll give you a immediately non-blocking but fairness-preserving semantics for try-lock. And then there's a bunch of other methods that sort of give you some information about the state of the lock. Is it a fair lock? Is it an unfair lock? Is it currently locked? It turns out that checking to see whether something is locked or not is actually not very useful, because the moment you check, it could be unlocked. So because of the atomicity properties of locking, knowing whether something is locked or not isn't really very helpful, because it could be stale by the time it returns you the value. And then there's also a very interesting factory method called new condition. And we'll talk more about this when we talk about Java condition objects. And it turns out that condition objects, which are yet another form of coordination mechanism built into Java synchronizers, will always require being used with a ReentrantLock. And so as a result, they go together. So new condition is a factory method that makes a condition object that's associated with that lock instance. And we'll talk more about that when we talk about condition objects. Okay, so that was a real quick overview of the key methods in ReentrantLock.